if you see this boundary, right? You see this x and this x, they have the same exact degrees. Usually, if they are the same or outside is higher, if outside is either same as this inside, so that means nothing can cancel. So that means there was a problem. Now, I did give you the best clue I can give it to you. Everything should be in terms of u. So the problem is, if they have the same degree, nothing can cancel. So that means they require something else. So also this x here, it can be greater. It can be x squared. The way to solve for this problem are exactly identical. But we start by organize what is u equal to x plus 1, du equal to dx. So far, not really a big issue. But you're going to get to this part. It's going to be square root u, and dx is going to be du. And the obviously part is this is in terms of u. This is in terms of u. The only problem is what? This x. It's a possible I change the x in terms of u. How?
Wait, so there is a u number 2?
U minus 1.
U minus 1, thank you. U minus 1 equal to x. So can I be like u minus 1, parentheses, square root u? Why is a parenthesis? Because you substitute something as a parenthesis. Now, what happened is you're going to get du here. You can distribute backwards. So that's going to be u to the 3 over 2 minus u to the 1/2 du. So u to the 5 over 2, 2 over 5. Minus u to the 3 over 2, 2 over 3, plus c. So now I can convert back to x if I wanted to. So it'll be x plus 1 to the 5 over 2 minus 2 over 3 times x plus 1 to the 3 over 2 plus c. And that's how you take care of this issue here. So here's a rule of thumb. I have a name for this one. It's called a back substitution. Now, I just asked, I don't know how many of you guys know Margot, senior. She took calculus with me last year. I just told her she just come back from Duke and she just visited me last period. I said, do you remember how to do this problem? Show everybody how to do it. Get on there. Kind of forgot a little bit of like basic stuff, but still, she did it with no problem. So yes, it's one of the things she said, yeah, just the one that you had to back substitute. And she even mentioned the right thing because I kind of gave you words to a certain situation so that way you remember what to do, especially if they have the same degrees. Inside the radical and outside the radical have same degree, or outside the radical has greater degree, they can be that way too. Okay, so that is the first one. Does everybody understand this or no? The only step is right here, and you guys just need to learn to look at everything that's given to you. That the clue is right here. Was only Daniel can find it, but everything should be in terms of you. I mean everything. Because why do I mention everything again? Is because the next question also the same thing. The next question is going to be integration between 0 to 1. Now, this is the first time we do definite integral with the u substitution. And you're going to be like, oh no, how do I do this? It's not bad. So 3 dx. Now, I'm going to mention something. This is the x value. This is also x value. Now, when I say it's everything in terms of u, that means even the boundary need to switch. You cannot stay as x. It's best is do it in terms of u because your problem, a process is going to be a lot easier. So you need to learn how to do it in terms of u. AP exam always push kids to do in terms of u, and there was 20 to 34%, 35% of students usually prefer to do it in terms of x. Now, why it's not beneficial? Because those 35% will get those questions wrong. It's probably 2 question multiple choice and 1 part of free response. So you have to make sure that you want to convert this to you. On multiple choice, you can even pay attention, just convert this. You would get half correct because they probably sometimes doesn't even ask you to do integral. It's just like which following is correct. So what happened is you're going to do u equal to x squared plus 1. du is equal to 2x dx. Make sure the plus 1 is not there. du over 2x is equal to dx. So now I'm going to do integration of x times u to the third dx. I'm going to change to du over 2x. Now, if you realize I didn't change the boundary there because I didn't want to put in boundary now, I want to make sure everything is terms of u. I don't want an x involved, right? Get it? You don't want your x get involved. Yeah. U to the 3 du. Now, the boundary need to switch. What I mean by that, I need to substitute the x value in there to have 1 squared plus 1, right? So that's equal to 2. And I'm going to switch that 0 squared plus 1 is equal to 1. So it's between 1 to 2. So the boundary both switched.
Wait, what?
I switched the boundary from 1 to 2, from 0 to 1, because I can plug in here, because this is an x value, this is x value, I can plug it both into here to evaluate for u value. Now, what happens if you're doing in u value, you don't need to convert back to x. Remember, some student want to convert back to x. No, you're just going to do u4 over 4 times 1 over 2 between 2 to 1. I did an integral. Then that's going to be 1/8 of 2 to the 4th minus 1 to the 4th. So it'll be 15 over 8. A very easy answer. I never went back to x. Don't go back to your x's. Got it? I'll give you a challenge problem now. Now again, every problem today is pretty challenging. Oh, I'm sorry. This is not big screen. My bad. Here. That's better to take a picture here. There you go. Does that make sense or no?
Yeah. Why did you do minus 1 to the 4?
Because it's u to the 4th. And I do 1/2 times 1/4, it's 1/8. So I just do it, plug in the u, which is u to the 4th power. Okay?
Wait, I get the 1/8. But why is it 2 over to the 4th minus 1 to the 4th?
Because you had to plug in the lower boundary into the u, and they had to subtract it. What? That's how you do the definite integral.
Why can't you go back to x?
Don't go back to x's. You're gonna regret it. Ever. In real life too. If you have an x, don't go back. That's the worst decision you can make.
Is it just like harder to like find?
It's just more messier.
Okay.
In real life too. I'm trying to give you a life lesson here. In the hidden code. Without getting canceled. Don't go back to x. Especially definite integral. Do not go back to x. Just do it in terms of u. Everything's going to result much finer. Okay, let me give you some hard problem. And if you get through this problem, you are super awesome. Martin is super proud of herself. She's like, I know, I can hear it from here. I expect 2 people got it right, and she's one of the 2 people. Okay, so okay, so this is a very challenging questions. The reason why there's so much challenge is you gotta make sure everything in terms of u. That's the first challenge. Second challenge, you gotta know how to, how to simplify algebra, how to take out constant. Those are things that make your life easier. So if you do it correctly, then that's good. If you don't know how to do it correctly, you gotta give it a try. It's good. You're done.
Yeah, like it's hold on.
You're not gonna make the same mistake again.
Hopefully not. I think I have a good pretty understanding. Yeah, this is like 8, and like I literally like wrote little things. Should be negative since it's below the axis. I was getting my facts in.
Yeah.
But do you?
Sure, I'll look at it. Let me look at that. You have nice handwriting.
Yeah.
I wish I had your handwriting. I'd be a much better teacher.
For real, it sounds like yeah, your writing is like chicken scratch. I'm like, what is this?
It's true.
Do you need this? Because I kind of want to keep the test.
You can keep it. You just need to modify your grade. Elisa, you fix everything?
Question what
Ask for help. Maybe Martin can help
yeah,
you. We're expert now.
I think the one which one? This one, it's from -5 to -2. So from this is there to there. It's the chart. So plus 2x.
Yeah.
And you were expecting to try
it's like split it up. Like this like you did like split it up. So that's like one, and you usually like copy and paste that, so that makes it there, and that's another one. So from like -2 to -5, like the area of that, and then that's just that. That's the answer for that.
So you guys copy down the questions?
And then
for this.
Yes?
so that one.
So I'm gonna go ahead and make a video about this. So you're gonna do this.
Yeah, find it in a row, which would be. And then I just plugged in.
And I'm taking derivative.
Plugging that in.
Evaluate for dx.
Okay, so you'll plug in -2.
Yeah.
So you'll get -5.
This one is gonna be between
Yeah.
1.
Yeah. And then
And I'll just do the boundary right now. I'm gonna go with square root of u.
Yeah, which is small.
dx. No. Nice try though.
wait, why is it?
So obviously dx is gonna change to du over 2 first.
You can make this all work.
Simple.
Oh, that was interesting.
Yes or no?
It's not right answer, but it's really close. Really close. This one require back sub. So I'm gonna do a back sub here. So it'll be u plus 1 2x, u plus 1 over 2 equal to x.
Actually, I'm on my test corrections. Wait,
Okay, I trust you. You can keep it though.
Are you sure?
I trust you. I just need to modify the grade.
Is it 2x minus 1 or x minus 1? Yeah, it's 2x minus 1. Yeah, 2x minus 1.
What?
Is it 2x minus 1?
Yeah, 2x minus 1. So this one's gonna be u plus 1 over 2 times 1 over square root u du
No.
and over 2. So it'll be 1 over 4 u plus 1 over square root u. What happened? It's really close. Some math is wrong. And that's equal to 1/4 integration. Split this. U to the 1/2. And the boundary, I'm gonna change the boundary as well. So boundary is gonna go with 5 times 2 minus 1. That's 9. And plugging 1, so it's gonna be 2 times 1 minus 1 equal to 1. So it's 1 to 9. So then that's equal to 1/4. U to the 3 over 2, 2 over 3. Plus 2u to the 1/2 between 9 to 1. I won't stay with the u, so I'm just going to plug in right here.
So you have the answer, one number.
Yep, 16 over 3.
That's the answer.
Mm-hmm.
In what world? Okay. I get this wrong. Oh, no, I didn't.
And there we go. That's my answer.